Hey everyone, welcome to part 7 of the Dream Home Build. We're going to be talking all about radiant heat in the subfloor. Now, as you know, we've installed radiant heating in the slab. We have a video on that. I'm standing on it right now, actually. But we also wanted to make sure we installed radiant heating in the entire main floor of the house. We have just over 2,300 square feet. It's all zoned out with radiant heating. Now, here's what we did. We ultimately chose to go with this probably stamped aluminum heat transfer panel. I would call it a U panel because it kind of looks like a U. And basically the way these work is they are a staple up installation where you put your PEX tubing, you kind of shimmy it in the channel, and you staple this up, as you'll see I will be doing later in the video. Now these are relatively inexpensive. They're readily available. I mean, I'll put the link for this one. I think it's by the company or brand Vevor on Amazon. But again, very much available, eBay, Amazon. And the other option I just want to quickly mention is extruded aluminum plates that go underneath your subfloor. Immediately there's a difference because they're a lot thicker, they are extruded, and the installation is a little bit backwards or opposite, meaning first you take the panel and you either screw it in or use some kind of fastener, probably not staples, against your subfloor, and then you jam or insert the PEX tubing, in our case half-inch PEX tubing, into the channel, this omega-shaped channel. The benefit, another benefit to these extruded panels is there are studies out there that say that when you use, because it's such a tight fit, I mean, I use a couple of these and I had to use a rubber mallet to get that PEX all the way in that channel. When you do that, the PEX tubing, when it has thermal expansion under heat load, it cannot expand from such a tight fit, and therefore it eliminates or at least minimizes any kind of noise that happens from that aluminum clicking or moving. I actually had a bit of a panic moment when we almost finished the entire installation, and I was reading that online and I'm thinking, oh man, I'm a really light sleeper. What if this thing keeps me up at night? So I ended up buying a bunch of these Omega channels, and I thought, you know what, at the very least, I will install these underneath the master bedroom where we sleep. And worst case scenario, at least it will be quiet in that area. But I can't say for sure if that's the case or not. We're not in that season yet. We'll get there. We'll make a video on that. We'll let you all know what we learn. The other reason we chose this installation method, like I said, it's relatively cheap. It's cheaper than the other option where you put panels or subflooring with radiant heat inside of it on top of your floor, meaning right beneath your finished floor product. This would be products like warm board or Rehau's product, which is called Rehau panel. Those products are immediately more expensive, and they can be a little bit more sophisticated for the installation, because if you want to finish your main level with solid hardwood flooring or something like that, you have to be mindful of where your PEX tubing is running. I mean, it would be pretty easy if it was all perpendicular, but in this house, all of our designs, no matter how we tried it in LoopCAD, we still had a lot of PEX tubing runs with the Rehau panel that ran parallel to the planned flooring installation, and I was really worried about that. And again, the pricing, it just made more sense to go with the underfloor installation. Now, I will say, we know for a fact that the panels that go above the floor, like warm board or Rehau panel, they are more efficient because you're taking that heat source and you're bringing it much closer to your finished floor. In fact, on a maximum load, which in our area is considered 0 degrees Fahrenheit outside, the system would be calling for 111 degree Fahrenheit water in the system to keep the house comfortable at max load. That's with the Rehau panel, with the panels on top. With the staple up method, it was calling for 122 degrees. So there's a difference there. Obviously you need more heat to get through the extra layer of sheathing and all that between the finished floor and where your actual heating comes from. Now in this video, I am starting off by preparing one of the biggest zones in the house, which will be the living room, the kitchen, the dining room, the laundry room, and the piano room. So I'm running a chalk line to snap a line across all of these floor joists so I can drill a hole that will accommodate all of the PEX tubing that will get looped into each joist bay. I want to give a huge shout out to Benjamin Salstrom, if I'm saying that correctly. Benjamin Salstrom on YouTube, who did a fantastic job of showing how to install underfloor radiant tubing. I referred to his video like many times when working on our radiant installation. The other thing is my framers installed a bunch of blocking all throughout the joist bays. This blocking is actually required by code to prevent fire from spreading too fast within the joist bay. It also provides lateral support for the joist bays above weight-bearing or load-bearing spots like the steel beam. Since I needed to run radiant PEX tubing through these joists, I unfortunately had to knock out many of these blocks. So, per the manufacturer's recommendation, we replaced all removed blocks with 2x4s. This is my little template, just a piece of 2x4. This tells me how far away I need to go from a load-bearing point, and also how far up I want that center of the pilot drill to be. That way all the holes for the PEX tubing are lined up, and also up where I want them to be. You can put them in a center. With these eye joists, there's actually documentation as far as what you can and cannot do. In my case, I don't have to center them. I can bring them closer to the supporting line, which is what I'm doing. That way it keeps the perpendicular PEX lines that run through a little bit higher up and out of the way of like duct and plumbing. I ended up drilling these holes across the entire span so that every radiant zone could be accessible. Now remember I showed you the aluminum U-plates? Well, they all come with a protective film, and I know people find it satisfying to remove protective film from appliances and stuff like that. Trust me, after 300 of these plates, it gets really old. Oh yeah, you absolutely have to have a powered stapler. I went with rigid stapler since I already was on their 18-volt battery platform. So yeah, you basically start at the end of your circuit, and while passing the PEX tubing through each joist bay, you make one loop. This way, you can then pull that loop out and run it down the joist bay as you see me doing right here. Annoyingly, I had to cut a lot of nails that either missed the floor joists or were protruding from interior walls up on the main floor. Of course, if the nail was in the way of the aluminum plate, it needed to be removed, obviously. But if it was completely out of the way, I still try to clean it up anyway, just to get it out of the way and make it look cleaner. I used both an angle grinder and an oscillating tool with a metal cutting blade. And honestly, either tool is fine. Hopefully you can also see how drilling my 2-inch holes up closer to the top of the eye joist made more sense. This reduced the angle at which the PEX tubing has to turn up and over, thus allowing you to staple the aluminum U-plate closer to the hole, and of course, as I mentioned, it keeps the entire system out of the way of other mechanicals. I found that the first aluminum plates are always the hardest to install, since the PEX tubing is immediately turning 90 degrees into the next joist bay. Oh, by the way, that little 2x4 block was an awesome little life hack. It allowed me to have a consistent spacing between the edge of the eye joist and the aluminum U-plate. I also made sure that this resulted in roughly an 8-inch on-center spacing. So at the time of this installation, I couldn't find any rules on how far to space each plate apart. So I just kind of eyeballed it to be anywhere between 2 to 3 inches. And I will point out that now the online vendors are recommending about 1 to 2 inches of spacing. So I guess I wasn't that far off. So my dad made a PEX spooler. I'm not gonna lie, that thing was a lifesaver. By the way, notice the supporting 2x4s over each steel beam. These allowed the aluminum plates to clear while still providing that necessary lateral support. We will eventually be adding rock wool insulation in all of the joist bays. This alone acts as a retardant for any potential fire. One of the nice things about these aluminum U-plates is they're easily cut to length using a miter saw. You can even cut several stacked together at the same time. The aluminum cut edge does have some burrs on it, so you might want to, get rid of them so that they don't end up, digging into the outer PEX tubing wall. And I made sure just to brush them off everywhere. We are fixing a kink in this PEX A tubing. We use this little heat gun here, little Amazon heat gun, and we heat it up for like 5 minutes. And it looks more round now where it used to be kinked, like almost bent. Now we're letting it cool off, and we're gonna let go of it because there's a bit of a twist to it as well. And hopefully once it's cooled down, it'll not wanna twist again. I'll let go of it, and it's round. It's a little wrinkly because I think the outside barrier gets melted a little bit, but according to the Rehau guy, that's not something to be worried about. One thing I haven't mentioned yet is every time I had a contractor on site, I always made sure to remind them both, via email, any kind of communication, and in person, that, hey, there's radiant heating underneath the subfloor, so make sure none of your guys ever try to run a nail or a screw into the floor. And you would think that some trades wouldn't even need to run anything through the subfloor, but you'd be surprised. It's better just to tell everyone who comes into the house that, hey, there is radiant installed here. All the kitchen countertops and stuff like that, they run through that bay. Yeah. So they actually didn't have it on the LoopCAD file. While I'm editing this video, I actually thought of a couple more tips. So one of them is toilet flanges. They say that because most, if you're using the traditional installation of using a wax seal ring for your toilet, you should try to keep the radiant heat PEX lines a little bit further away from where that hole is. That way you don't get a concentrated area of heat that could potentially start melting that wax seal ring. The other thing is, obviously, if you have any kind of floor registers where the ductwork is kind of sharp on the corners there, make sure that you not only go around the ductwork, but you also actually have clearance between the metal corners, because if that PEX tubing is moving or expanding or anything like that from heating up, you don't want it to rub on a sharp edge and just, and within a month or a year, chew a hole through itself. This is the mother of all manifolds. 10-station manifold. Which means you have 10 circuits. Which means you have potentially 3,000 feet of PEX tubing. I am at ODFL, Old Dominion Freight Lines. We came here to pick up a bunch of bubble foil insulation because it wasn't going to get delivered on time, but it was at the hub, and the hub is really close to the house. So that is those boxes, and then more boxes over there. Since radiant heat actually radiates in all directions, kind of like the sun, you need to reflect it back up towards the subfloor. That is what the bubble foil insulation is for. Now here's something that I was never really able to get a clear answer on. We installed the bubble foil about 2 inches below the PEX tubing. So technically the tubing is never coming into direct contact with the bubble foil insulation. Now, would it make a difference if you stapled the bubble foil directly under the PEX tubing? I don't know. Maybe someone who knows the answer to this can leave it down in the comments below. I'd like to know the physics reason behind it.
So we're gonna have the HVAC people come in this week?
Yeah. Now the reason you see some joist bays with bubble foil and then some not was because our HVAC contractor was going to be on site, and we wanted to focus on the joist bays that would have ductwork, since installing the bubble foil insulation after the fact would be incredibly difficult. The same goes for the entire area where the main trunk lines run through. You'll see those in just a moment. So this is a 2-zone supply section right here, coming out of the, it'll be a top supply out of the unit, the blower unit. And this is a splitter with just a regular little baffle probably valve in there. So this little trunk right here, if I back up, it's not very long, but it's gonna serve the basement supplies. And this way, the basement is on a separate zone than the main floor, which is the main trunk here in the middle, which is gonna probably go all the way. It might step down to a smaller size, but it'll go further out than it is right now. And I don't know, in my experience, your basement's never quite the same temperature as your main floor, and the requirements, or the amount of BTUs it's asking for is not the same. So having some kind of ability to control your supplies separately is nice. In other words, to zone it. Now, of course, you can get really fancy and you can put automated little motors on there. I think they're like low voltage motors that control the zones based off of what the thermostats are calling for. But in other words, you're ultimately no longer sharing a supply run between the main floor and the basement. So in this case, you have to have additional runs going through, because now each run is dedicated to either the main floor or the basement. For instance, this run right here and this run right here. And then there will be a third run right here, where originally you would just probably up the size of your pipe, your duct, and you would share the same one with the basement and the main floor. And if you wanted to control the flow between the two, you would probably only be able to do it at the floor registers, where you can shut them off or close them off a little bit to reduce the airflow in one zone or the other. Other than that, though, the whole basement and the whole main floor are single zone. So in other words, this house has 2 zones, the basement and the main floor. It's not like your master bedroom has a separate zone altogether. Now we're talking heating and cooling with air. When it comes to the radiant heat, of course, that's a whole different game. Talk about that. So, but this is just the blown air, the forced air approach.
And yeah, let me elaborate on that. We have radiant heating installed in the house for the winter time only to heat the house, but we still need a central AC unit for cooling in the summer. And I know it sounds kind of like a waste, but since we installed the radiant heating on our own, we saved a ton of money. Now, I know there's a lot more we can talk about when it comes to radiant heating. I mean, we haven't even talked about the mechanical, like the boiler room and all that. And that's because there's going to be a future video dedicated to all of the mechanicals of it. So, and just a little spoiler, it's going to be a geothermal system. So if you're interested in such a thing, then definitely stick around and maybe even subscribe to the channel, it wouldn't hurt.